Welcome to Spelling Bee Ninja, your go-to source for free educational content. We're on a mission to inspire curiosity and learning in every listener. If you're excited to explore the incredible connections between different subjects, especially how math and music intertwine, you've come to the right place. Be sure to subscribe and join our community of learners as we dive into today's topic, the fascinating world where math meets music. Today, we're unraveling the intriguing connection between mathematics and music, two fields that may seem worlds apart but are intimately linked in surprising ways. Whether you're a budding musician or just someone who loves a good tune, understanding this relationship can deepen your appreciation for both math and music. Let's start with the basics: sound. When musical notes are played, they're created by sound waves that vibrate at specific frequencies. This frequency is a critical mathematical concept, measured in hertz, which tells us how many times a sound wave vibrates each second. For example, the note A above middle C, often referred to as A440, vibrates at 440 Hz. Considering how these frequencies interact gives us insights into why certain notes sound good together. Higher frequencies yield higher pitches while lower frequencies bring about deeper tones. If we double the frequency, like going from A440 to A880, we move up an octave, which is again firmly rooted in math. Each octave represents this doubling relationship, revealing the math behind our musical scales and our understanding of rhythm. Now let's dive deeper into the significance of these frequencies. In music, we not only create melodies through individual notes, but we also generate harmony. Harmony is produced when two or more notes are played together, and this harmony is defined by the mathematical ratios of their frequencies. These ratios establish whether the combined sounds are pleasing or discordant to our ears. For instance, an octave, which maintains a 2:1 ratio, sounds harmonious. Meanwhile, a perfect fifth resonates at a 3:2 ratio, while a major third sits at a 5:4 ratio. These simple relationships create the delightful sounds our ears find pleasing. Historical figures like the ancient Greek philosopher Pythagoras were among the first to explore these musical ratios. Pythagoras made groundbreaking discoveries about how different string lengths produce distinct sounds, laying the intellectual groundwork for understanding music through a mathematical lens. Fun fact: Pythagoras believed that the planets produced harmony as they moved in space, a concept he called the music of the spheres. Now let's consider how we organize rhythm in music. Rhythm relies heavily on fractions and division, reminiscent of mathematics. This brings us to the concept of time signatures. Time signatures, like April 4th or March 4th, inform musicians how beats are grouped within measures. The upper part of the signature tells us how many beats are present, while the lower part indicates the type of note that counts as one beat. For instance, in the 4/4 time signature, we have 4 quarter notes per measure. These are basic mathematical divisions that musicians must understand to play and compose music accurately. The most common time signature, for fourths, is so widely used that it's often referred to as common time, its signature marked with a C. It's found in most pop, rock, and classical music, illustrating just how mathematical concepts govern our musical experience. We can't overlook the extraordinary role of musical scales, which are built on mathematical principles as well. Take the major scale, for example. This 7-note scale follows specific interval patterns defined by frequency ratios, creating distinct sounds when played sequentially. The pattern of whole steps and half steps in a major scale is represented as WWH, with W standing for a whole step and H for a half step. This structure echoes through various scales across cultures, but a notable Western system employs the equal temperament method, a revolutionary mathematical approach developed in the 16th century. It divides the octave into 12 equal parts, giving musicians the flexibility to play in any key without sounding out of tune, a substantial leap forward in musical composition and performance. As we explore deeper into composition itself, we find that math is not merely a tool for understanding how music works, it is embedded within music's very structure. Composers often utilize mathematical patterns and sequences to craft their works. This might include the repetition of melodic ideas, transformation of these ideas, or even the use of complex forms like canons. An interesting occurrence is the Fibonacci sequence, a mathematical sequence where each number is the sum of the two preceding ones. Some composers have found inspiration in this pattern, allowing it to influence the structure of their music. Renowned composers such as Mozart and Beethoven intertwined these mathematical patterns to create pieces that resonate emotionally while maintaining structural integrity. Speaking of complex structures, let's also examine the golden ratio, approximately 1.618, which often appears in the realm of music composition. Many famous composers have strategically placed central themes or climaxes within their works at points that reflect the golden ratio, enhancing the emotional impact of the music. For example, one can find representations of the golden ratio in Mozart's sonatas and Beethoven's Fifth Symphony. Even the physical design of musical instruments can exhibit this elegant mathematical relationship. The way instruments are constructed, particularly string instruments like violins, conforms to mathematical principles that enhance their sound quality. The shapes and dimensions employed in crafting a violin affect its tone, and some of the finest violins ever made were developed using sophisticated mathematical proportions. Moving into the realm of digital music technology, we encounter another facet where mathematics plays an essential role. Digital music recording relies heavily on numerical data, essentially samples of sound waves taken thousands of times each second. This means that every digital audio involves a vast amount of mathematical processing. Algorithms are employed for various functions, including sound compression, effects like reverb and pitch shifting, and even the synthesis of new sounds. The Fourier transform, a mathematical concept, is utilized to analyze and manipulate audio in remarkable ways, revolutionizing how we create and listen to music today. Without the mathematical frameworks that underpin this technology, we wouldn't have the extensive capabilities we now enjoy with digital recordings, streaming services, or the electronic music landscape that many have come to love. Finally, what is it about the connection between math and music that continues to captivate and inspire thinkers, artists, and scientists? This relationship reveals that beauty is often crafted from logic and structure. Both mathematics and music designate their own forms of expression, yet they share a language of patterns and emotional resonance. Music is often seen as audible mathematics, while mathematics is sometimes poetically referred to as silent music. This duality, an acknowledgement that beauty and logic can coexist, has enchanted generations of creators and scholars. The great physicist Albert Einstein, also an accomplished violinist, spoke about how music influenced his physical theories, highlighting the profound impact of this relationship. Today, discussions surrounding the correlation between math and music remain vibrant. Understanding this connection not only enriches our knowledge but also allows us to experience music and math through a more profound and appreciative lens. To wrap up, we've uncovered the beautiful intersection of mathematics and music. From frequencies and sound waves to time signatures, scales, and digital technology, each facet illustrates how numbers and patterns shape our musical experiences. Remember, every time you hear a melody or enjoy rhythmic beats, there's a silent math at work behind the scene, enhancing beauty and expression. This connection empowers not just musicians but anyone who appreciates the harmony found in both disciplines. Thank you for joining us on this journey into the world of math and music. We hope today's exploration has sparked your curiosity and inspired you to look at both math and music with fresh eyes. Don't forget to subscribe and dive into more engaging educational content that feeds your mind and creativity. Until next time, keep seeking knowledge and enjoying the symphony created by numbers and sounds.